next thing I want to talk about is coterminal angles. Again, in the pre-calculus book, that's in section 4.1. Coterminal angles are just angles that if I draw them in standard position, so that of course means that we're starting with the initial ray on the positive x-axis, the terminal ray of the angle is the same. So here I've drawn in an initial ray and a terminal ray. That's not actually enough to tell you what angle I'm talking about, because there are a lot of different ways that I could get from this initial ray to this terminal ray. The simplest is just to rotate in the positive direction like so. But I could also rotate once around and then a little bit more. I still started on the positive x-axis and ended on that same terminal ray. So those two angles that I've just drawn, one of which was an acute angle and one of which was more than a full revolution, those are what we would call coterminal. I could also have started on the positive x-axis and rotated in the negative direction. I still end up at the same place. That's also a coterminal angle. Okay. So what I want to do is, it looks to me like this angle, and I did this on purpose, it looked to me like that was about 45 degrees. I'm going to work with this one in degrees. We'll do the next one in radians. Okay. What I want to do is list two positive and two negative angles coterminal with 45 degrees. Okay. And then I want to list all angles coterminal with 45 degrees. Okay, so I can sort of see, I think I maybe wanted to use a different color for this one. If I look at this one, the way I got this first coterminal angle was I went around once and then I went that 45 degrees. So for the positive angles, I could say, well, 45 degrees plus one full revolution, so plus 360 degrees. That would give me 405 degrees. That is an angle that is coterminal with the angle 45. Okay. If I wanted to get another one, let's just go around again. Okay. So that would give me 45 degrees plus two copies of 360 degrees. I'm just going to add two revolutions. So let's see, that's 720 plus 45, that would be 765. Or I could have also just added 360 to the 405 that I had right here. Okay. Now, if I want to get some negative angles that are coterminal with 45 degrees. Okay. Here, I started here and went around like so. Notice, another way I can think about that is I started here, I went 45 degrees, and then I said, oh, wanted to go in the other direction, so I backtracked a full revolution. So that would basically be 45 degrees, which takes me to here, minus 360. Undo that 45, and then go the rest of the way around. So I could view this as 45 degrees minus 360 degrees. Go there, subtract a full revolution, and that's going to give me negative 315 degrees. And then, of course, if I wanted to get another negative angle that's coterminal, once I've gotten here, go around another time in the negative direction. So that would be 45 degrees minus 2 times 360 degrees. And again, I could get that by just subtracting 360 degrees from this, so that would give me negative 375 degrees. Okay. Now, if you're asked to just list two positive and two negative, there are lots and lots of answers. These are the simplest ones, but you could certainly come up with other ones as well. If we wanted to list all of them, notice all of these I got by taking 45 and adding or subtracting a multiple of 360 degrees. So what I can do is I can say all of the angles coterminal with this are 45 degrees plus n copies of 360 degrees, where n is an integer. Okay. Now, integers include 0 and the counting numbers, so 0, 1, 2, 3, 4, 5, but it also includes the negative, or the opposite of the counting numbers, so negative 1, negative 2, negative 3. So even though I'm writing this as a plus, if my n happens to be a negative integer, for example, if n was negative 1, we're talking about 45 degrees minus 360 degrees. So I don't have to write the plus and the minus 1 separately. I can just say, hey, it's my angle plus any multiple of a full revolution, any multiple of 360 degrees. Notice if n happens to be 0, which is a perfectly valid integer, then I just get 45 degrees. Because certainly 45 degrees is one of the angles that in standard position has this as its terminal ray. Okay. So to get all angles coterminal with a given angle, we just add a multiple of the angle corresponding to a full revolution. In degrees, that's 360 degrees. Now, it is necessary when you introduce this variable n that you tell me it's got to be an integer. Because if this were allowed to be any real number, it could be something like a fraction. It could be a half. Well, 45 degrees plus 180 degrees is not coterminal with that. I need it to be an integer. Now, there is a shorthand for saying that n is an integer. Okay, so I can write, I'm going to do it over here, n, this little e-looking thing, and then a fancy z. Okay. This fancy z, you've sort of seen similar notation. The set of real numbers is often written this way. When we use a z instead, this is just the set of integers. Okay. And this little e formally means is an element of. That's why it looks like an e. So this is saying n is an element of the set of integers, which is just a fancy way of saying n is an integer. Okay. So I'll often use that notation just because it takes a lot less time than writing out in words that n is an integer. Okay. So, and since we're going to often be looking at coterminal angles, I recommend that you get familiar with that because it does save a lot of writing. It is necessary if you introduce an n that's standing for an integer that you tell me that it's standing for an integer. Okay, fabulous. Okay. So let's just do the same thing with an angle in radians. Let's say I took pi over 6. Now I know that happens to be the same angle as 30 degrees, but I want to work in radians, and I want to do the same thing. I want to find 2 positive, 2 negative, and then all angles that are coterminal with pi over 6. Okay. I'm going to recommend that you actually pause the video and give that a shot, and then tune back in and check your answer. We'll compare notes. I've got my answers worked out up here on the board. For coterminal angles, pi over 6 was already positive, so if I wanted to get more positive, I'm just going to add a positive revolution. So we're adding a multiple of 2 pi. Okay. Now, when you're working with radians, you often will be working with fractions. So in order to add pi over 6 and 2 pi, I did need to get a common denominator. Let me just show you over here. 2 pi, I can always write that as a fraction by just putting it over 1, and then I wanted a denominator of 6. So I just multiplied by 1 in the form of 6/6, and that gave me 12 pi over 6. Okay. And so then I did the addition, got 13 pi over 6. If I add another revolution to that, I could either view that as pi over 6 plus 2 full revolutions, which would be 4 pi, or I could just add 2 pi to this one, Either way, I'm going to get 25 pi over 6. Again, if you added more than 2 revolutions, if you took pi over 6 and you added any positive multiple of 2 pi, you would get a positive coterminal angle. For the negative ones, I chose to subtract multiples of 2 pi. Now do be careful. Here, pi over 6 was an acute angle. So if I subtract a full revolution from that, I'm going to get something negative. But if I start with a really big angle, if I started with something like 5 pi, if I subtract 2 pi from that, I don't get a negative angle that's coterminal with it. I get 3 pi, which is coterminal with it, but it's still positive. So do make sure that you subtract enough full revolutions that you get a negative result. Here we started with a small enough angle that just subtracting 2 pi, which again I converted to 12 pi over 6, gave me 11 pi over 6, and then subtracting another copy of 2 pi gave me negative 23 pi over 6. Finding all of them is actually simpler because you don't have to do the math. You just write pi over 6 plus 2 pi times n, so that's a multiple of 2 pi. Don't forget then to tell me that it's an integer multiple. So n, either write out n as an integer, or this is the shorthand for n as an integer. N is an element of this fancy z, which stands for the set of all integers.